1.3. Let's see detailed each and every set. Okay, before proceeding with the mathematical definition of empty set, let's see an example. Consider the first set. Set A is equal to X such that X is a student of class 11 presently studying in a school. Okay, so from this, how we will say the answer, we can go to the school and we can count the number of students presently studying in class 11, right? So I can say the set contains a finite number of students, right? So for example, let's take your school only. For example, if I can say class 7 is having total strength of 35, it's possible for us to count. Now move on to the second example. Be X such that X is a student presently studying in both class 10 and 11. It's not possible. A student cannot study in both the classes 10 and 12. So the set B contains no element at all. There is no common. Okay, both means common. There is no common student in 10th and 11th. Now we'll move on to the mathematical definition of. Okay. See this example. Set A is equal to X such that X is an even prime number greater than 2. Okay. The prime, what are all the prime numbers? Actually the prime number is 2, 3, 5. I mean the number which is divisible by itself, right? So here it's given even prime number. We know that 2 is the only one element in the prime number series. That too the even element in the prime number series. But here see the question, even prime number greater than 2. It's not possible. Okay, only even prime number is 2, but they are asking the number even prime number greater than 2. So it's not at all possible. So what is the answer? The set is empty. Either you use this notation or simply write 5. Okay. Let's see another example. Set of odd natural numbers divisible by 2. So odd a natural number starts from 1 to infinity. Odd natural numbers means 1, 3, 5 and it goes on, right, up to infinity. But it given odd natural numbers divisible by 2. Is it possible any odd number is divisible by 2? No, not possible. So what is the answer for this set? It's an empty set or null set or void set. Okay. Now we'll move on to the next set, finite or infinite set. Okay. Let's see finite and infinite set. Again, before proceeding with the mathematical definition, let's see first see an example. That A is equal to 1, 2, 3, 4, 5. B is equal to A, B, C, D, E. And C is equal to men living presently in different parts of the world. So how many number of elements are there in the set A? Totally 5, right? How many numbers are there in set B? Same 5. And what about C? Men living presently in different parts of the world. How many elements can you say in the set C? Okay, so as it is, we don't know the number of elements in C, but it is some natural number, but maybe quite a big number. Okay, but we say some natural number for the set C. Okay, now consider the set of all natural numbers. Can you say the number of elements in natural numbers? No, it's not possible, right? Why? We say the set of natural numbers is infinity, right? So the set A, B, C, this A, B, C are finite, and this example, let's say this is set D. Set D is our infinite number. Okay. Now we'll move on to the mathematical definition of finite and infinite sets. Okay, a set which is empty or consists of a definite number of elements is called finite set. Otherwise, the set is called infinite. Okay, a set which is empty or consists of a definite set. So, empty set also we'll consider it as a finite set. Let's see a few examples in finite and infinite sets. Yeah, consider this example. The set W is equal to set of the days of the week. Okay, so what are the days of the week? We know it's Monday, it's Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. So it's possible for us to count the days of the weeks, right? 1, 2, 3, 4, 5, 6, 7. Therefore, total number of days is equal to 7. Therefore, it's a finite set. Now, we'll see an example for the infinite set. Set A is equal to X such that X belongs to natural numbers and X is odd. So What are all the odd natural numbers? The natural number starts from 1. 1 is an odd number. 1, 3, 5, and it goes on, right, up to infinity. So we will not, up to infinity. So when we represent a set in roster form, we write all the elements of the set within the braces. Yes, it's not possible to write all the elements of an infinite set within the braces. So what we will do, we'll write few elements of the set and then we will put this dittos, okay, inside the bracket. So all infinite sets cannot be described in the roster form. For example, we can say the set of all real numbers. Set of numbers we cannot represent it in the the roster form. Okay. Next, we'll move on to the equal set. Okay. Now we'll see the equal set. Take two sets, set A and B. If every element of set A is also an element of set B, and if every element of set B is also an element of A, then we say that both the sets are equal. Okay. So this is a mathematical definition of the set. Two sets A and B are said to be equal, the equal set, if they have exactly the same elements. I told you, no, the elements of set A is there in set B, and the reverse, this elements of set B is there in set A, means we will say both the sets are equal. So we will write that as A is equal to B. The capital letter set A is equal to set B. So otherwise the sets are said to be unequal, and we write A is not equal to, this is not equal to symbol, so A is not equal to B. We have to find whether these two sets are equal or not. See the question, X, the set of letters in the word alloy, B, the set of letters in the word loyal. Okay, how we will write? We will write everything generally in the roster form. But in roster form, we noted that while writing in roster form, an element is not generally repeated. So we are not supposed to repeat the element. Okay, now see this. Let's see the solution. What's your X set? X is A. L, I told you we are not supposed to repeat the element, therefore O, Y. This is our X set. Now what about the B set? L, O, Y. We are not supposed to repeat L again. Okay. Now see the number of elements in X set is 4, and here number of elements as 4. The elements you see, whether is there X set elements are there in B? Yes, they are. See, A is there, L is there, O is there, Y is there. Therefore, these two sets are equal. See this problem, from the sets given below, select equal sets. So there are totally 1, 2, 3, 4, 5, 6, 7, 8. 8 sets are given. We have to select the equal sets. See set A, it's 2, 4, 8, 12. B is 1, 2, 3, 4. C is 4, 8, 12, 14. D is 3, 1, 4, 2. E is minus 1, 1. F is 0, A. G is 1, minus 1. H is 0, 1. We have to select the equal set. Let's take set A. And let's see whether any other equal set is there or not. A is having 2, 4, 8, 12. But C is having 4, 8, 12, 14. 2 is not there, so it's not equal. B, 1 and 2 and 4 only there. 1 and 3 is not there. 8 and 12 are not there. D, same. E, no other. So A is not equal to any other set. Now we'll move on to the B set. 1, 2, 3, 4. See, D, 3, 1, 2, 4. Only the order has changed, but the elements are same. 1 is there, 2 is there, 3 is there, 4 is there. Therefore, B is equal to D. Okay, now let's check any other set are equal. We'll move to the C set. See, 4, 8, 12. 14 is not there, and here 2 is not there. Therefore, C is not equal to any other set. Okay, D already we said D is equal to B. Now we'll want to E, minus 1, 1. C, the G set, 1, minus 1. Again, the order only has changed. Therefore, E is equal to G. What about the other sets? There is no set common to each other. Therefore, only two sets are common. One is B is equal to D. Another one is E is equal to G. Till this is your exercise 1.2 students. If you have any doubt, kindly write it in the comment box or you text us through email ID. Thank you. Don't forget to subscribe.